Alright, we are going to solve a problem on resultant vector, that is the sum of two vectors. Okay, let's go ahead. Let A equal to 17i plus 25j, B equal to 4i plus 5j, C equal to 3i plus 5j. We have to find the scalars lambda and beta if C is the resultant of lambda A and beta B. Now, the idea is that the resultant of two vectors is actually the sum of the two vectors. So if you add two vectors together, you are going to obtain a resultant vector. Now, the question is saying that C is the resultant of lambda A and beta B. So what is lambda A? What is beta B? That's the first question. Solution. Lambda A will be obtained by multiplying this vector A by what? The scalar lambda. So let's multiply this by lambda. We have 17 lambda I plus 25 lambda J. Then to obtain beta B, we are going to multiply this by what? Beta. So it will now be 4 beta I plus 5 beta J. So if C is the resultant of this and this, that means 3i plus 5j, 3i plus 5j is equal to the sum of these two. That's what this question is saying. 17 lambda I plus 25 lambda j plus 4 beta I plus 5 beta j. Alright, let's go ahead. Let me write it again so that everything will be on one line. 3i plus 5j equal to 17 lambda I plus 25 lambda j plus 4 beta I plus what? 5 beta j. Here we have in terms of I and in terms of j. So that's what we also have here in terms of I and in terms of j. So see what I'm going to do now. I want to reduce this. Since these two are in terms of I can say 17 lambda plus 4 beta. I'll bring the I out. And since these two are in terms of j, I can also say plus 25 lambda plus 5 beta. And bring the j out. So here I have 3i plus 5j. So it is now simplified. I will now do what we call comparing coefficients. Okay, comparing the what? Coefficients. So I have in terms of I at the left hand side, and I have that in terms of I at the right hand side. So their coefficients are the same. 3 is equal to 17 lambda plus 4 beta, equation 1. Also, 5 will be equal to this since we are having j. So 5 is equal to 25 lambda plus what? 5 beta. Of course, we can simplify this equation by dividing by 5 to obtain 1 equal to this divided by 5 is 5, and this divided by 5 is what? Beta, equation 2. So I'm having two equations here. What I'm going to do is to what? To solve them simultaneously for lambda and beta. Okay. If I want to eliminate, let me see that will be easier to eliminate. It will be easier to eliminate beta first. Yes, it's easy. I'm having 4 here. So I can multiply this by 4, equation 1 by 4, so that this beta will contain 4. You get the point? So if I multiply this by 4, I'll have 4 times 1, 4, times 5, 20, plus 4 beta. Let's say equation 3. Good. So I can easily do something now. They are the same. 4 beta, 4 beta. Since they have the same coefficient now, I can just subtract any of the equations from the other. I can say equation 3 minus equation 1, or equation 1 minus equation 3. Let's say equation 3 minus 1. 4 minus 3 is equal to 20 lambda minus 17 lambda plus 4 beta minus 4 beta. They will cancel out. What's left here? 1. And this will give me what? 3 lambda. Now this will say, if I divide both sides by 3, lambda is equal to 1 over 3. This is it for lambda. So let us now determine the scalar. What is it? Beta. So it is easy to get beta now. What we have to do is this. In place of lambda now, in let's say equation 1 or equation 2, let's make use of equation 2 since it looks simple. You can just put lambda here. So I'm putting 1 over 3 for lambda in equation 2. So we have 1 equal to 5 times 1 over 3. You get the point? 5 times lambda plus what? Beta. So 5 times 1 over 3 is 5 over 3. 1 is equal to 5 over 3 plus beta. So beta will now be equal to 1 minus this. 3 times 1 is 3 minus 5 over 3. And that's what? Minus 2 over 3. So beta is minus 2 all over 3. So this is it for the very problem that we have on the board. It's been solved. Thanks for watching. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like and share the videos to your friends and your classmates.